Hello, this is Gleb Yakov, and this is implementation of a Python notebook, which is needed for homework 2, and then required some of the modifications for the Python network file. So when I run everything, you can see that everything is calculated, and basically the cross entropy log likelihood and mean square error functions corresponds to the values you can see in a homework description output. So in order to achieve this, I had to modify the evaluation function. So for the evaluation function, I added some output, and also for each of the values of the output layer, and I calculate the activations from the feedforward function, and also I getting the maximum index from the output layer and corresponded with the activation function here in order to calculate the log likelihood. Also, I calculate the cross entropy and mean square error as a separate function, which are here. So basically, I'm providing the output layer and also activations here. In order to output, to print out everything, had to make a separate function also, which is output results. And hw2 function has a parameter print output, which will let you output everything to the screen. Also here it will save all of the history for the training and testing sets in a separate list, and you can print it out also, so it will return as parameter. In a hgd gradient descent function, here I implemented the early stopping, where basically it will check for the current accuracy, and if it's accuracy more than or equal than 10%, then I will return the list, history list, and also output the current output for the current epoch. Also for the backpropagation, I made some changes to the initialization of the activations list. So instead of this dynamic list, to not compromise on the memory allocations, I basically initialized all of the activations as zeros first, and provided as necessary dimensions, which are stated in the sizes parameter. This function doesn't change much, but basically what I'm doing here is I'm going through all of the layers, and index here is a layer in the activations list, and calculating dot product between the current weights and the activations. And also, if the activations will be set to first output here, like this is the first layer. So the next layer will be calculated, and then this dot product will be this dot product. Out of this product, I will calculate a sigmoid function, and I'll save it as a next layer. So basically that's it. Also, I made some kind of write up and some additional visualization plots that you can see in my report. Thank you.